Hello learners, welcome to Dr. D.Y. Patil Vidyapith's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me Statistics and Quantitative Techniques. In this video, we are going to learn Markov chain and Monte Carlo simulation. So let us start with Markov chain and let us try to understand what exactly Markov chain events are. So a sequence of events which can also be called as outcomes. So sequence of events or outcomes in which an event depends upon the immediately preceding event but not on the prior events. It's called as Markov chain. So Markov chain is a sequence of event in which an event depend upon the immediately previous event and not on the earlier events, not on the prior events. So this is called as Markov chain. The examples of Markov chain can be market shares for product during month or year. So market share for product depends upon the immediately preceding event, immediately preceding month's market share, and the condition of machine to be used for production each week depends upon the immediately previous condition of the machine and not the prior events. So these can be the examples of Markov chain. Now let us try to understand Markov chain and Monte Carlo. Monte Carlo methods are a class of computational algorithms that rely on repeatedly random sampling to compute their result. So a few things which we must understand from this particular definition is that Monte Carlo are some computational mathematical methods which consist of algorithm and that rely on repeated random sampling. Now random sampling, these are the two important words we must understand in this particular definition. Random means whenever we conduct any experiment and the outcome of the experiment are random in nature, then such experiment is called as a random experiment and the outcomes generated are random outcome. So whenever we conduct an experiment or whenever we assign some values to the outcomes of an experiment, that becomes the random variable. So random variable is a variable which consists of values which are assigned to the outcomes of an experiment. For example, if we conduct an experiment of tossing a coin, then there will be two outcomes, head and tail. So we assign some values to the outcomes of an experiment, then such a variable is called as a random variable. So sampling is when it is not feasible to study entire population. It might not be feasible to study entire population because of economical constraint, time constraint, and therefore we conduct a representative portion of the entire population in order to study the entire population. So this particular method is called as sampling. So random sampling means random means the values assigned to the outcomes of the experiment is random variable, and sampling is taking representative portion of the entire population to compute the result. So we make use of some mathematical computational algorithm along with repeated random sampling to compute the result of an experiment. So Monte Carlo methods consist of computational algorithm that rely on the repeated random sampling to compute the result. Then Monte Carlo methods are often used when simulating physical and mathematical systems. So whenever in many situations where we have to simulate the physical as well as mathematical situation, in such a situations Monte Carlo method is very useful tool. So because of their reliance on repeated computation and random and pseudo-random numbers, Monte Carlo methods are most suited to calculation by a computer. So Monte Carlo simulation is based upon the repeated computation and random and pseudo-random numbers. So therefore the Monte Carlo simulation is very useful and is suitable to the calculation by a computer. Monte Carlo methods tend tend to be used when it is feasible or impossible to compute an exact result with deterministic algorithm. So, whenever it is impossible or unfeasible to compute something, compute the result of some experiment, in such a situation, Monte Carlo methods are used. It is also used with deterministic algorithms. So, whenever we have some data, some information with certainty, then in such a situation, such kind of experiment are called as the deterministic experiment. So in such deterministic algorithms, whenever it is impossible or unfeasible to calculate so many things, in such a situations we use Monte Carlo methods. Simulation procedure. Now let us understand the simulation procedure. Step 1 is to identify the input variable, collect data on them and write down probability distribution for them. So input variables that decides the output, right? So we must understand what are the different types of input variables. We must collect data uh, regarding the input variables, write down the probability distribution. So we must understand the probability distribution of input variables also, and this represent the simulation model. So this is the first step. So we identify input variable and their probability distribution. So probability distribution is a graphical or tabular arrangement of random variable on x-axis, and we can say probability of random variable on y-axis. That is what is probability distribution. So what is probability distribution? Again I repeat, when we represent a random variable on x-axis and its probabilities on y-axis, the graph we get is probability distribution. It can be the probability distribution can be represented graphically, or it can be represented in the form of table also. So in a table, in the first column we can have a random variable, and in the second column we can have the probability of random variable. Step 2 is rewrite the cumulative probability distribution. So we can easily calculate the cumulative probability distribution from the probability distribution. In the step 3, we need to identify the random number intervals corresponding to these cumulative probability figures. So we must have to identify the random number intervals. We must have to find out the random number intervals. So if the probabilities are expressed in 2 decimal digit, so when we have probabilities mentioned in the 2 decimal digit, for example 0.25, 0.39 like this. So if the probabilities are expressed in 2 decimal digits, we have to use the random numbers from 00 to 99, and if the probabilities are mentioned in the 3 decimal digits such as 0.125, 0.239 like this, then we have to use a random number interval from 000 to 999. Step 4. Prepare a table for the random numbers to be generated to simulate the model. So we have to prepare a table for the random numbers which are to be generated to simulate the model and expected values of the input variables. Step 5. Generate n random numbers if not given from the random number table. Start with any number in the table and proceed in horizontal, vertical or diagonal direction to select n numbers respectively and consecutively. Step 6. Process this simulated information and then interpret and summarize the results. So applications of simulation. Computer models to imitate real life or make predictions are also the type of simulation. So we use many computer models which help us to imitate the real life situation or make prediction or make forecast regarding some some result. So they are also the types of simulation. The forecasting done by the weather department, the forecasting regarding the sales can also be called as simulation. So one can simulate the demand, one can simulate the forecast for the demand, right? So even the Excel models have a certain number of input parameters and a few equations that use those inputs to give you a set of outputs. So whenever we compute something in Excel, we have to provide it some input values right? And based upon some input values, we use some formula also, some equation also. So by putting these inputs in that equation, we get output in Excel also. So Excel, so we often call it Excel modeling. So that is nothing but Excel simulation. So the on the right hand diagram, you can see x1, x2, x3. These are the input variable that goes into a model, right? So in a model, there is a formula, there is a functioning, there is a processing, and the input variables are converted into output variable. This type of model is generally deterministic, meaning that you get the same result no matter how many times you recalculate. So it doesn't matter how many times you recalculate it, how many times you repeat it, you get the same result again and again. So this kind of model is called as deterministic model. Markov chain Monte Carlo is a general computing technique. So it is a computing technique that has been widely used in physics, chemistry, biology, statistics, and computer science. Monte Carlo simulation. So Monte Carlo simulation is a method for iteratively evaluating a deterministic model. So there is a step-by-step iterative method for evaluating a deterministic model. Deterministic model means when we carry out some experiment again and again, the result will be same. So using sets of random numbers as input. So we use some random numbers as inputs. This method is often used when the model is complex, nonlinear, or involves more than just couple of certain parameters. So this method is very complex in nature, right? So whenever we come across business situations which are very complex in nature, which are nonlinear, or which involves more than just some parameters, then we have to rely on Monte Carlo simulation. A simulation can typically involve over 10,000 equations of the model, a task which in the past was only practical using supercomputers. So a simulation model can consist of 10,000 of evaluation. There can be 10,000 of equations, right? So which will be processing the input variable and giving out the output. In example below, we used simple uniform random numbers as the input to the model. So as you can see here on the right hand side, there is a diagram. In this diagram, x1, x2, x3, these are the input variables. Now each of them have different probability distributions. As you can see, x1 is different than x2. From this diagram only we can predict what kind of distribution it is. So as you can see here, the x1 is the negatively skewed distribution. x2 seems to be having normal distribution, and x3 is assuming uniform distribution. So inputs variable have different types of probability distributions. Then this variable goes into a model for processing. So in a model there can be n number of computations which will be done on the these input variables, and that will give us output variables in the form of y1 and y2 here on the diagram. So each of them will again have different probability distributions. So in example, we used simple uniform random numbers as the inputs to the model. However, uniform distribution is not the only way to represent uncertainty. So the x3 variable here in the diagram assumes uniform distribution. So we have used uniform distribution here to represent the certainty, but uniform distribution is not the only way to represent the uncertainty. Before describing the steps of general Monte Carlo simulation in detail, a little word about uncertainty propagation. The Monte Carlo simulation is just one of many methods for analyzing uncertainty propagation. So what we do in Monte Carlo simulation, basically we try to predict, we try to forecast some events, some outcomes which are based upon the previous outcomes, right, by using some model, computational model. So that is what Monte Carlo simulation is. So Monte Carlo simulation is one of the many methods for analyzing uncertainty propagation, where the goal is to determine how random variation, lack of knowledge, or error affects the sensitivity, performance, or reliability of the system that is being modeled. Monte Carlo simulation is categorized as a sampling method because the inputs are randomly generated from probability distribution to simulate the process of sampling from an actual propagation population. So we, as already discussed that, so we use random numbers as inputs to the model of Monte Carlo simulation. These random numbers have their own, probability distribution, and we use it to simulate the process of sampling from an actual population. So we have already understood what is sampling. Sampling means taking some representative portion of the population. Population is the totality of the items under study or under observation. Out of them we take some representative samples or portion to study the entire population. So this method is called as sampling, right? So we try to choose a distribution for the inputs that most closely matches we already have or best represent our current state of knowledge. The data generated from the simulation can be represented as probability distribution or histograms, or converted to error bars, reliability predictions, tolerance zones, and confidence intervals. So we can have confidence interval which are shown here in the output variable y. So we have these two vertical lines here, right? So these are nothing but the confidence intervals. This is a sine wave type of output. Then we have confidence interval again in the y2 variable. So this is how we can generate outputs. So that's all about Monte Carlo simulation and Markov chain. So I hope you have enjoyed this particular video, and thank you for watching the video. Keep watching the videos.